The info in this section isn't necessarily new. It's stuff you already know, but we're just putting it all together. So you know that zeros of a function are where a graph crosses the x-axis. So let's say we have a negative 0 and a positive 0. So we have negative a and positive a. And a can be any number you want it to be. Then we just move right over here and write down the factors. So if the 0 is x minus a, the factor is x plus a. And if the factor is positive a, or if the 0 is positive a, then the factor is x minus a. Nothing new. What we're going to do today, though, is we're going to take those factors and we're going to write a polynomial out of them. How do we do that? We FOIL or box, whichever you prefer, your factors. So whatever your factors are, you're just going to FOIL or box them, multiply them together. So we will write a polynomial, and these are the 3 zeros. Those are the 3 places where it crosses the x-axis. At -3, at x equals 1/2, and at x equals positive 1. If those are the zeros, then x plus 3 is a factor, x minus 1/2 is a factor, and x minus 1 is a factor. So we have to FOIL or box 3 things together. So it's all right, we're just going to pick 2 to start with, and then we'll multiply that answer by the third one. So I'm going to go ahead and pick the first factor and the third factor, and I'm going to FOIL those together. So I'm FOILing x plus 3 and x minus 1. When I do that, I'm going to get x squared minus 1x plus 3x minus 3. Combine like terms in the middle, and we get x squared, -1 plus 3 is positive 2x, and then minus 3. So that takes care of 2 of the factors. Now we have to take that answer, this one right here, and multiply it by the factor we haven't used. So you have a choice. I'm going to get rid of the equal sign just to save space. You can write the other factor right in front, and if you are a person who likes to distribute and FOIL that by multiplying there, there, and there, and here, whoops, here and here, you can go ahead and do that. But you know that I like to box when things get pretty big, so I'm going to erase that and set up the box. Okay, it turns out I can't erase it, so I just drew a box down below. The 3 terms are on top and the 2 are on the side. So we'll start boxing. X times x squared is x to the third. X times 2x is 2x squared. And x times -3 is -3x. -1/2 times x squared is -1/2 x squared. At this point, you might want to start writing the -1/2 as -0.5. If you're doing that from here on out, that's fine. Either are acceptable. Next, we have to multiply -1/2 by 2. In other words, 2 divided by -2. That gives us -1x. Or if you type in -0.5 times 2, you'll get -1. And then -1/2 times -3. That's going to be positive 3 over 2, or if you're working with decimals, it would be 1.5. So now we just need to combine like terms so we can write our final answer. I only see 1x to the third, so that's all by itself. I see x squared's right here. So depending on how you want to subtract this, it's 2 minus 1/2. That's going to be 1.5 or 1.5, whichever way you want to write it. Next, we have -3x minus 1x. That's -4x. And last, we have our 1.5 or 3/2. So that's the final answer. For this example, I didn't give you any fractions, so you're welcome. Those are the zeros. Those are each what x equals. So we have factors of x plus 2, x minus 2, just flipping the signs to put them in parentheses, and x minus 4. So in this case, it doesn't really matter which two you FOIL or box first. I'm just going to go ahead and FOIL the first two together. Go ahead and work through this as far as you can get, and then you can check your answer in a couple minutes. You should get x squared minus 4 when you FOIL the first two factors together. Now we'll take that answer, and we will multiply it by the one that we didn't use yet, by the x minus 4. So we can FOIL or box that together. And your final answer should look like that. There's no like terms to combine. So we get to learn the fundamental theorem of algebra. You've been using it pretty much this whole time. Every polynomial, as long as the degree is bigger than 1, has at least one zero. And the zeros might be real, so they might actually cross the x-axis, or they might be imaginary, which means they might be floating. So it all depends on what the highest degree is. See how in this polynomial, the degree was 3, and there were 3 factors? Those were 3 real factors, because it actually crossed the x-axis in those 3 places. Same with over here. The polynomial is x to the third. There were 3 real zeros. Well, we might not get 3 real zeros all the time for something like x to the third. We might get 2 real and 1 imaginary. We might get 1 real and 2 imaginary. It just depends. So that's what the fundamental theorem of algebra says. If you can only find 2 real ones, it means the other ones are imaginary. So let's try to find all the zeros, real and or imaginary, for these functions. So when we first look at this, we see it's x to the 4th. So there's going to be some combination of 4 zeros. It's already set equal to 0. We can look for a GCF, because that's always the next step when factoring. And I'm noticing a bunch of 1s in front of here. So the biggest number is a 1, and that 8 doesn't have an x. So there is no GCF. It would be great if we could group or unbox this, but there's 1, 2, 3, 4, 5 terms. And that'd be a weird looking box. So what we're going to do is we're going to use the rational root theorem, or use a calculator to figure out where some of the real zeros are. That's going to be our first step. Find some real zeros. How do we find real zeros? It's where it crosses the x-axis. So to save time, I grabbed my graphing calculator, I typed that into y equals, and I looked at the graph. And when I did that, I saw a graph that kind of dipped like that, and it appeared to go right through -2, and it also appeared to go right through +1. Those are called rational roots. They're places that are not decimals, so I went right through those places. So since we know those two are real, we're halfway done with the problem. That's one root, x equals -2, and x equals 1 is another one. Those are both real. So it must mean that the other 2 roots, since there's 4, are imaginary. So we are going to use synthetic substitution using the roots and kind of narrow this thing down until we can factor it. So I'm going to take my -2, put it in the box, and start doing synthetic substitution. So I'm bringing a 1 down, a 1 down. Oh, by the way, let's see if we have any skips. 4, 3, 2, 1, nothing. Okay, no skips. So 1, 1, 2, 4, and -8, just like you were practicing in section 6-4. We'll drop down the 1. -2 times 1 is -2. 1 minus 2 is -1. -2 times -1 is +2, and 2 plus 2 is 4. -2 times 4 is -8, and 4 minus 8 is -4. Last, -2 times -4 is +8, and -8 plus 8 is 0. So of course we got 0 for our remainder because we knew that -2 is a root. So this, instead of starting with x to the 4th, Now this starts with x to the third. It's 1x to the third minus 1x squared plus 4x minus 4. We could try factoring that. It has 4 terms. I'm not writing it down because we could unbox it, but since we already know another root, we're going to do the exact same process again. So I'm going to keep these coefficients right there. I'm going to put a 1 in the box and do the same thing again. And how about I do this next procedure in blue so we can kind of tell them apart. So now I'm putting 1 in. So drop that one. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. 4 plus 0 is 4. 1 times 4 is 4, and negative 4 plus 4 is 0. And of course it was 0 because we knew that 1 was a root. So now that we have done synthetic substitution again, now we can cross off x to the third. So these coefficients are going to go with x to the second, x, and then no x. So this is what we're going to factor. X squared plus 0x plus 4 equals 0. Now we can solve this. We're going to have a hard time coming up with factors of 4 that add up to get 0 because 2 plus 2 is 4 and 1 plus 4 is 5. So we can't factor it this way like we normally would want to, but it's all right. What we're going to do is, since we don't have to factor it that way, I'm going to get rid of that 0x in the middle, and we're just going to use the equation x squared plus 4. To get the x all by itself, I'm going to subtract 4 to the other side. We'll have x squared equals 0 minus 4 is negative 4. Square root both sides, and the square root of negative 4 is plus or minus 2, and since that negative's underneath there, it's 2i. So those are the other 2 zeros. The third 0 is positive 2i, and the fourth 0 is negative 2i. And now we have all 4 zeros, 2 real and 2 imaginary. This last example is sort of interesting. There's only two terms here. We could try getting the 16 on the other side and solving that for x, but we'd have to fourth root. And unless you can fourth root on your calculator, which there is a way to do that, I'm going to show you how to do this by factoring. So we should notice from when we were practicing factoring that this is a perfect square if we square root it, and so is this. This is also a minus sign, so it means the middle dropped out because it was 0. So what times what equals x to the fourth? X squared and x squared. What times what equals 16? 4 and 4, and when one of them's positive and one of them's negative, we'll get 0 in the middle. So now we try to just keep going and solve each of those for x. So why don't we just do what we did on the last step of the previous example and set each of them equal to 0. Oops, it's minus 4. So we're going to do that, and then we'll get our 4 answers. So in this side, we will minus 4 from both sides, and x squared will equal negative 4. When we square root it, we're going to get plus or minus 2i, because we're square rooting a negative, so there are 2 of the zeros. And on the other side, we can just add 4 to both sides, and we will get x squared equals positive 4. And when we square root that, we get plus or minus 2. So these 2 are the real zeros, these 2 are the imaginary zeros. You can leave them like that, or you can choose to write positive 2, negative 2, 2i, and negative 2i. I'll accept either.